This is the review for concept quiz 23. In this problem, we're considering this data set and deciding which one has the smallest standard deviation. So standard deviation is defined as the average distance from the mean of all of the numbers in the set. The first thing you need to do here is figure out the mean for each set. So I've written here x bar, which is the average of the four numbers that are listed in the table. And those are the averages of the other sets. Now, in these spots here, I've also written how far away from the mean each of these numbers is. So 30 is 30 away from 60. 60s here are both 0 away from 60. And 90 is also 30 away from 60. So you do that for each one. Make a list of how far away these numbers are from the corresponding mean. Now, once you've done all of those, you're looking for the set that has the smallest standard deviation. We can automatically rule out set B because those numbers are all larger than these. Now, A and C have the same standard deviation. D, let's look at that and compare it to these. Here, the average distance from the mean, if you average out 0 and 30, that's 15. Here, average of 15s, all 15s is still 15. So in this case, all these sets A, C, and D have the smallest standard deviation. How do you know? They all vary the least on average from the mean. Alright, now on part 2, if you divided each number in set B by 15, indicate which two of the following statements would be true. So in a transformation where you're dividing by a number, all of the measures are going to be affected. So all of the measures are going to end up being divided by 15. So standard deviation would be divided by 15 is true. The standard deviation would not change. That is not true. The standard deviation would decrease by 15. That's saying that you're subtracting 15, which is not true. You're dividing. The mean would be divided by 15. That's true. The mean would not change is not true. Mean would decrease by 15 is also not true. Alright, now on part B, you're given a dot plot with some data, and you are finding the measure of center that best represents the data. So measure of center is referring to mean, median, and mode. So we're being asked which of those would best represent the number, or which type of pet most of the class has. So when you look at data like this that's not symmetric, you can't really say that the mean is the best representation, because you have this data over here. We say that this is skewed right because most of the data is over on the left and we have a few data points over here on the right. Anytime you have data that's skewed right, it's the median that's most appropriate, because if you listed this all out, you're finding the middle of the data set, not the average of the data set. Why? Well, this data is skewed right. Alright, let's see, part C, consider the following data set, select all of the statements that are true. Well, I'm going to just write these in order to make it a little bit easier here. So 3, 12, 15, 21, 30, 39, and 48. Okay, median is 22.5, so median represents the middle of the data. The middle is exactly 21. I think I'm missing a number here. Oh, I forgot the 24. So I'm going to add that in. Let's see. So now the middle of the data set is the average of 21 and 24. Average of 21 and 24, so let's add them together and divide by 2, is 22.5, so that is actually true. The set has no mode, meaning there's no number that occurs most frequently. That is true. The range is 36, so the range represents the difference between the highest number and the lowest number. So 48 minus 3 is not 36. And the mean is 24, so let's just double check that. Add up all the numbers. 24 plus 30 plus 39 plus 48. And divided by, we have 8 data values. The mean is 24. All right, part D, we have height of 5 Christmas trees. What is the mean height of the trees? Let's go ahead and do that. Add them all up. And divide by 5. Oops. Okay, divided by 5. The mean is 13 feet. The standard deviation of the heights. So let's look at the standard deviation formula. Rather than writing the formula down, I'll kind of just walk you through how to calculate standard deviation. So you are going to take the difference between each of these heights and the mean and make a list. So 15 and 13, difference is 2. 12 and 13, the difference is 1. 17 and 13, difference is 4. 11 and 13 is 2, and 10 and 13, the difference is 3. So we're looking at the average distance from the mean. We're taking all of those distances, we're going to square all of them, add all of those together, divide by the number of pieces of data, which is 5, and lastly, square root. Alright, so if we evaluate that, we have 4 plus 1 plus 16 plus 4 plus 9. We're going to divide that by 5 and then square root that answer. So 2.61 is the standard deviation. Alright, now the mayor is selecting trees to be displayed in front of City Hall. He only wants to choose trees that are within 1 standard deviation, so that could be above or below. So if I take the average height, I'm going to add 2.61 and subtract 2.61 and see what the range of heights that are okay is. So 13 plus 2.61 is 15.61, and then 13 minus 2.61 is 10.39. So the trees that are within that range of heights, A isn't going to work, B is fine, C isn't going to work, D is fine, and E is not going to work. Okay, the last problem here, we have 4 members plus a coxswain on a rowing team. To be eligible, the average weight of all 5 people in the boat must be 178. The 4 rowers that we know are these weights here, but we don't know the weight of the coxswain, so I'm going to represent that as X. So the average of all of these weights, so I'm going to divide by 5, should be 178. So if we set up that equation, now you should be able to solve it. So multiply both sides by 5. So this would be all of this equals, if you multiply this by 5, this is 890. And then if you subtract all of this from 890, you should get your answer. So 890 minus 186 minus 192 minus 172 minus 157 will give you a weight of 183 pounds.